Good afternoon, ladies and gentlemen, and welcome to our next lecture about Gelita RXL. Gelita RXL is a specially designed gelatin with reduced cross-link performance for capsule applications. Today, I will only focus on the soft capsule side. I would like to firstly introduce myself and the company Gelita I'm working in. My name is Maren Kohler, and I've been working at Gelita for about 12 years now. My background is food chemistry, and I'm a technical product manager within our RBD, Research and Business Development Department. Gelita itself is with a market share of about 26%, the market leader in the collagen protein industry. Collagen proteins comprises gelatin, pharmaceutical, edible, technical grade gelatin, but also collagen peptides. Possibly you know Fortigel and Verisol, our bioactive collagen peptides. And a third part are also partly soluble collagen, like our Pargel product. Okay, I will first give a short introduction for people who are not so familiar with gelatin. What is gelatin, what is collagen, and then we will focus on Gelita RXL. We have different types of Gelita RXL based on different raw materials, on bones, bovine hides and pigskin. Today I will focus on bovine hide and bone gelatin. Okay, people who are dealing with it know what is pharmaceutical gelatin. It's covered by the monographs. According to the European Pharmacopoeia, it's defined as a purified protein obtained by partial acid hydrolysis, our type A gelatin. This is mainly the pigskin gelatin. By partly alkaline hydrolysis, type B gelatin. This is bone or bovine hide gelatin. And also, or it could be treated by enzymatic hydrolysis, resulting in non-gelling gelatin. It's done, or it's hydrolyzed collagen from animals, including fish and poultry. This is also regulated by the monograph of the European Pharmacopoeia. Difference to the USP is that the non-gelling gelatin is not covered by the USP, only the type A and the type B gelatin. Raw material for our gelatin, or for gelatin in general, is native collagen, mainly from bovine and porcine origin. It could be skins, bones, and sometimes also from fish and poultry. Of course, all raw materials that we are using are from healthy slaughtered animals approved for human consumption. What is collagen? Because it's so important for us. It's a fibrous protein. It's the most occurring protein in mammals. It's not only one protein. It's a family of proteins. About 27 different types are known. Important are type 1, 2, and 3. Within one species, type 1 collagen is identical from skins, bones, and tendons, and comparing different species, it's very homologous. Important is the triple helical structure of collagen. You have 3 protein chains that are intertwined to form a rigid strand. The helical part contains 1,014 amino acids, and the molecular weight of these triple helix is about 290 kilodalton. Looking what is happening from collagen to gelatin, we first have a pretreatment and then an extraction just by water, so that this triple helical structure is destroyed, and then after gelling you have a reformation partly of the triple helix. Just an overview about production. As I said before, you have an acid or an alkaline pretreatment. Then you have an extraction just by water. In the batch process, it's with different temperatures of water. Then these extracts are purified by different steps. concentrated up, dried, investigated, of course, in QC lab, and after that it's milled, sieved, blended according to the customer requirements and according to the application it's used for. Okay, coming now to the capsules. Gelatin capsules are the industry standard because they offer a high bioavailability, protect active ingredients against oxygen and light, and present a neutral taste and odor. And of course, they promote a very good patient compliance. But gelatin could get insoluble or partly insoluble, especially under extreme storage conditions, the ICH 4075, for example, or under extended shelf life requirements. An additional point could be unusual shell compositions, or if there are some residue of certain metals that could cause cross-linking. Another point could be a pellicle formation, a shell-fill interaction, especially with problematic fills like herbal extract, where the fill isn't released after storage. Yeah, what is the idea? Was the idea of Gelita to reduce the cross-linking? The idea was to increase the level of the collagen peptides that are present in the gelatin. And the result was then our Gelita RXL. It could add value to the capsules and enhance the capsule dissolution properties. As I said before, shelf life is improved, especially at high temperatures and humidity. And additionally, you could explore new fills that could be encapsulated before for certain markets. It's protected by patents in the US, China, Indonesia, Mexico. They are already granted, and in other countries they are pending. Additionally, I think what is very important to know is that it's pure gelatin, pharmaceutical and edible grade gelatin. There are no additives, no modifications, so that it could be used also for H&N products in the US. There is no limitation. Okay, to have a look at the background of the cross-linking in gelatin, especially the free amino groups of the lysine and hydroxylysine are very reactive. Also, the free carboxy groups of glutamic acid and aspartic acid could react and could cause these cross-linking. Looking at the self-cross-linking within the shell, it could be that the free amino group of the lysine and the free carboxy group react, so that you get a bigger molecule, at least twice as big as before, and this could cause dissolution problems. If you have reaction with aldehydes coming from the fill, there could be also a reaction and cross-linking problems. Another point, as I said before, could be that metals like chromium, alumina, copper could react, and also the molecular weight would be very high and the gelatin does not dissolve anymore. To overcome this issue, we have these very small collagen peptides adjusted in the gelatin so that they can react with the gelatin, block it, and the molecular weight increases only by about 5% and is still soluble. This is true for self-cross-linking, but they also, of course, could react with aldehydes. Okay, looking back, it means that gelatin shell dissolution is compromised, implying cross-linking. A pellicle could form, entrapping the fill, and our solution is Gelita RXL. Looking forward, Gelita RXL bone is performing better than standard lime bone gelatin. This is what I'm going to show. Gelita RXL bovine high gelatin is better than standard high gelatin. And a third point that we haven't expected, but it is like this, that Gelita RXL hide even performs better than standard lime bone under our test conditions, of course. We started with films, but then, of course, also make capsule trials at the University of Heidelberg in the pharmaceutical technology. A modified Changsung Type 3 machine was used with these conditions. As a shell formulation, we used our, let's say, standard shell formulation, 44% gelatin, and then glycerol and polysorb, both 11%, and the remaining was water. And as a fill formulation, we just use PEC 400, European Pharmacopoeia quality, a very pure quality where the formaldehyde is specified as not more than 5 ppm. A very good quality. I think we tested it about 2 ppm in the beginning. And of course, you know that formaldehyde causes this cross-linking. We put some glycerin in to reduce the migration from the shell. And we used as a model for the release a brilliant blue, because we didn't add any actives. We stored the capsule under 4075 and 3065 ICH storage conditioned, open and closed in bottles. We don't have the possibility to blister, so that we said, okay, we have the very drastic opened and we have the closed, and of course blister is something in between. Then we stored also at 2250, and up to now we have results up to 1 year. We know, of course, that according to the requirements of the pharmacopoeia, the 4075 storage is only necessary for 6 months, but we wanted to see in our model how good is the gelatin, and it's only a model. Of course, if you add other substances, it could be different. As a dissolution kinetics, we use the USP Pedal 2 equipment, medium water, 37 degree for 50 RPM, and we detected the dissolution of the gelatin and the release of the brilliant blue. The gelatin parameters we have chosen for the first part, for the lime bone and the RXL part, very similar. Gelatin, usual soft capsule qualities, 160 Bloom, 3.2 millipascal seconds for the viscosity. And finally, it resulted in a gel mass viscosity of about 9 to 11,000 millipascal seconds. As I said before, we measured shell dissolution, this red curve, and the fill release, the blue one. We could make it simultaneously with an automatic dissolution equipment. Okay, starting with the lime bone, first have a look at the shell dissolution, the gelatin cell dissolution. I've chosen here only the most drastic conditions. The 4075 storage, first open. If you can see here, starting with a red line, the red line is for the fresh capsules. Then we have the 3-month blue, 6 months green, and the black is the 12-month curve that you can see after 12 months. Only a slight delay, but a delay of the shell dissolution. But it's only a slight delay and after 1 year. Looking at the Gelita RXL bone, there is no delay in shell dissolution. Looking at the fill release, marked by our brilliant blue, you also only can see a marginal delay after 12 months and no delay at the RXL side. Then going to the closed storage conditions, we see after 12 months a delay for lime bone gelatin, looking at the shell dissolution, and for the RXL again there is no delay. Looking at the fill release, it's much more drastic. The standard lime bone, you really have trouble after 12 months with the fill release. For the RXL, there is no delay. This is now both curves for shell and fill, and you can see that only a very short part of the shell of the gelatin is undissolved, but the release is very, very bad. That means that a pellicle has formed. And at the RXL side, it's unchanged. No pellicle formation. Then we go 4075 open 12 months. You have a slight delay in the release. And this is open is better than closed, because open you sometimes see hydrolysis of the gelatin, and that's what you couldn't see under closed storage conditions. And for the RXL, it's even faster than for fresh capsules after 12 months, also again because of the hydrolysis that you have under 4075 open storage conditions. Okay, why is that, and what is happening with the gelatin? Looking at the molecular weight distribution of gelatin, you can see this is for fresh capsules, lime bone, the 100,000, the alpha chain of the gelatin, 200, 300, and this is the microgel. This is the high molecular part. It has a molecular weight of more than 400,000 Dalton. And then you can see after 3 months, 6 months, and 12 months that the 100,000, the part is decreasing, and the high molecular part is increasing. And this is cross-linking and, the impede of the fill. Looking at the RXL side, Gelita RXL, again you have your 100,000, the microgel here, you have the small peptides. 3 months, 6 months, 12 months, again you can see that this is decreasing, but the high molecular part is more or less unchanged. So that, you can see there is not happening cross-linking very much. Okay, as a summary, for lime bone gelatin capsules, only a mild cross-linking is occurring after 12 months at 4075. For closed storage, there is a clear evidence of a pellicle formation, and in open storage, a delay in fill release. And for the RXL, you still have an excellent performance after 12 months at 4075. Molecular weight analysis has shown that it's growing the high molecular part due to the cross-linking. Okay, this was the first topic, that the RX bone performs better than the standard bone gelatin. Okay, the second part was that we compared different lime-tight gelatin qualities. Different to the viscosity. These 4 types are more or less standard types in a viscosity range of about 3 to 4 millisecond second. One is 3.9, the other is 3.2. And additionally, we have chosen one with a less or lower viscosity, but also could be good used for soft capsule production. Gel mass viscosity was in the range of, let's say, 8,000 to 15,000, 10,000 for the lower viscosity. This is therefore higher because I forgot to say that for this low viscous type, we have adjusted a little bit the gel mass composition. We used a little bit a higher gelatin and plasticizer concentration to get a gel mass viscosity you can work with in soft capsule production. Again, or here we only have the fill release, 4075 storage open for the low viscosity type, the 2.5 millipascal seconds. You can see that there is a little bit the dye release slowing down. The red curve are for the fresh capsules, the black one after 12 months. And at the RXL side, there is no delay in dye release. Looking at the 3.3 viscosity a little bit higher, you clearly can see that already after 3 months, you have a drastically slowing down of the dye release. Compared to the RXL, there are not these changes, no cross-linking. And then most drastical is the high viscous, but it is a viscosity that is used for soft capsule production. Already after 3 months, there is more or less no dye release anymore. The RXL type is quite good, no problem. Let's summarize it. Lime-tight gelatin capsules have a viscosity-related cross-linking problem. The higher the viscosity, the faster the onset of the dissolution problem or issue. Gelita RXL in comparison, you can see very good fill release already also after 12 months and also for the high viscosity levels. So that customers can choose what viscosity level they would like to work with or what is in their files, what they have to use to. And with the RXL types, it's quite good. So second summary is Gelita RXL height performs better than the standard height gelatin. Last but not least, we have compared limed bone gelatin with limed height gelatin. We have a standard limed height gelatin. We have chosen the viscosity of 3.2. In comparison, a limed bone with the same viscosity and an RXL limed height gelatin. Looking at the fill release, 4075, closed storage 6 months. You have, as you can see, a delay in the fill release for the standard limed height gelatin. In comparison, the limed bone is much better, but compared to the RXL height, the green curve, this is still better than the bone gelatin. This was really surprising for us. It was not what we were expecting, but in this model, this was really the result. Okay, let's summarize. The Gelita RXL height outperforms limed bone gelatin in our system. There is cross-linking problem with limed height gelatin. This is known, especially, let's say, in the South America where height gelatin is used, mainly used, they can observe these cross-linking problems. Limed bone gelatin, that is often used or seen as the gelatin as the industry standard for capsules, has less problems of cross-linking, but you can also observe after certain times and storage conditions also some cross-linking. And in comparison, our latest generation of Gelita RXL height gelatin performs even better than the standard limed bone gelatin. Okay, in conclusion, we can say that Gelita RXL is a solution for cross-linking challenges. Thank you for your attention.